Our next step is to make our code object-oriented. In other words, we're going to pull out some of our code into a class. If you're unfamiliar with classes in C++, take some time to review object-oriented programming in this language now. We're going to make two classes, one for relays in general, and one for relays controlled by GPIO pins. This second class will be a subclass of the first. The first relay class will make it easy to swap out different hardware if we decide to control our relays in a different way, while the GPIO relay class will allow us to add additional functions to each relay without having to repeat our code over and over. Alright, we've gone over the basics. We know how to control relays, but now we're moving on to the next step of organizing our code better into classes. And because we're going to have multiple files, we're going to want to use the particle project structure, and that's going to require a little bit more setup beforehand. So instead of just creating a single file, I'm going to go ahead and say particle project create. It's going to prompt me for a title for my project. I'm just going to call this traffic box. I don't want to create it in the default directory. This is because I've picked a specific spot in my file system where I want to put this folder, but it doesn't really matter. It just depends on where you want to put it. So I'm going to say yes for putting it in my current directory. So if I cd into traffic box, you can see there are a couple things in here. There's a readme, project properties, and an src folder. If I cd into src, you can see there's a trafficbox.ino, so it actually generates that for me. To create the other pieces of my project, I'm also going to need to make a library. To do this, I'm first going to want to make a lib directory, and then I'm going to want to call my library relay, because this is where I'm going to put my files that will contain the information about my relay class. So I'm going to say mkdir relay, cd relay, and then I'll say particle library create. I'm going to name it relay. I'll just call the version 1.0.0. You have to have it in that specific format. I'll just put my own name for my library. This doesn't really matter because no one else is going to be using this library. I can put whatever I wanted. Alright. So now, if I list what's in here, you can see it auto-generates this examples directory, which, if we look inside, there's just this single directory usage. So I'll say cd usage, and then there's just a usage.ino. We don't really care about that, though. Oops, sorry. So, you know, the usage folder is there just in case we were giving our library to other people, but since we're more just making a library for our own purposes, we don't really care what's in there. So if I look back, what's in here, more importantly is the src folder. So if we look inside, you can see we have our relay.cpp and our relay.h files. So those are what we're going to go ahead and edit first. Here I have my relay.h file open in Atom. You can see a lot of stuff already gets pre-filled in, but you can see it adds in comments like relay library by Danny White. You know, we have to include particle.h because it's not our just main INO file. You know, part of the advantage of the INO file type is that we don't have to have things like include particle.h because it's an INO file type. It gets added in automatically. But since this is just a .h file, it doesn't do that. I'm going to go ahead and delete some of these comments. So we're making our main relay class. You can see that there's a space for our private members and our public stuff as well. We're not going to end up having anything that's private. The reason why we want to have some elements that are protected and not just private is we want the subclass of relay to be able to access them. We're not going to need the begin and process methods. We are eventually going to need a constructor, so I'll leave that in there for now, but let's go ahead and first add what we have that's protected. I'm just going to add a few variables. First, our max timeout. So that's going to be the maximum amount that you can set our timeout to be. It makes sense for it to be unsigned, right? We're never going to have that be negative. We'll also just want to have a unique ID for each relay. This count variable is going to keep track of how many times the relay has been turned on. And then we have state, which will be either 0 or 1, depending on whether or not the relay is on or off. Alright, and then for our constructor, I'm going to say we're going to ask for an ID, and I'll want to have a constructor that asks for an ID and a timeout. I'll want to have some virtual functions like my destructor, as well as our on and off. The idea here is we want to force these to be implemented. I'll also want to have a set timeout method. And the reason my parameter is ms is because our timeout is in milliseconds. We'll also want to be able to return our timeout. And then I'm going to just set up the rest of our getters. And the reason why we're adding the const at the end here is we want to be prepared for these functions to be called with things that are constant. And that's it for our main relay base class. Next, however, though, I want to set up a class that's a subclass of relay. This is going to be called GPIO relay. And the idea here is, normally, right, we've been controlling our relays using the GPIO pins on our electron, which is fine, but we might set them up to be controlled some other way. So that's why we have this relay superclass, and then we're creating the GPIO relay class to deal specifically with relays that are controlled using GPIO pins. So I'm going to call it GPIO relay, and it's going to derive from relay. This timer object is actually something from the particle library itself, so that's why I'm just saying timer. And then, of course, if it's a GPIO relay, it will also have a pin associated with it. So what do we have that's public? We, of course, have our constructors, which have to accept the same things as the superclass, except with the addition of a pin. We'll also have our destructor, and then we'll need our methods for turning on and off, as well as a method for setting our timeout. Lastly, we will have one private part of this class as just going to be our setup function. And now we have our header file set up. Alright, now we're ready to work on our CPP file. You can see this is still my relay.cpp, so I'm still inside of my library. I'm just working on the other file that was automatically generated. You can see that it auto-generated a lot of code, including the functions that I had declared in the header file, but since we deleted those in the header file, we're going to delete them here too. We're now ready to actually set up our constructors, so we have to have the same parameters, the same arguments that we had when we declared it, and then we'll initialize everything else to default values. And then we don't actually have to do anything inside of the constructor. We need to do the same thing for our other constructor. Next, we'll set up our getTimeout function. And since this is a getter, all we have to do is say return max timeout. We have to set up our setter for the relay timeout. And so I'll just say max timeout equals ms. And then I'll do something similar for the rest of my getters. So that's everything that we had declared in our header file. So that's everything we're going to add for just the relay class. Now we have to set up the GPIO relay class as well. Just like before, we'll have our two constructors, which will take the same arguments that we set up in our header file. And you can see that we're calling the constructor of the superclass. So you can see in this constructor, we didn't just have nothing inside of our brackets, or instead calling the setup function, which is where we'll actually set up our hardware. We didn't have to do that in our base relay class because the whole point of the base relay class is that it's not associated with any specific type of hardware, so it's not like we can actually set any of that up. We also have our destructor. And the only thing that we're going to do here is make sure that we clean up our timer properly. So if we've created a timer, so if it's not null, we'll say timeout dispose. And that's just one of the functions that timeout has. It's how you can get rid of one of your timers. Next, we'll want to create our setup function. So if we had a timer before somehow, we'll want to make sure that we've cleaned it up. It's just sort of a safety measure. If we've been passed a timeout that's greater than 0, that means we'll want to have a timer. So we'll create a new timer. What the arguments we're passing in mean is, first, the timeout for the timer, you could probably guess that, the callback for the timer, so what gets called when the timer runs out. The whole reason we're creating a timer is because we're going to miss some transmissions from the phone. We're going to sometimes not receive the on signal, which we can't really do anything about. But we know that if the relay is turned on, we should expect to be turned off eventually. But if for some reason we miss that message, we want to turn it off anyway after a certain amount of time. So that's why our timer calls GPIO relay off. We also pass in our instance, and then whether or not it's a one-shot timer. We don't want this timer to keep going after it's timed out. You know, if we turn the relay on and then we time out on it and we turn it off, we don't want to keep turning it off over and over and over again for some reason. We just want to turn it off once, and then we can restart the timer if we get turned on again. And then if we're not past something greater than 0, we'll just make our timeout null. Just like before, we'll still need to configure our pin as output, and then we'll also make sure it's written low at the beginning. Next, let's set up our on function. So since the whole point of our count is to keep track of how many times a relay has been turned on, let's increment it. And then just to be sure, let's make sure that our state is indeed off, and then set state to be 1, and say digital write pin high. And then if our max timeout is bigger than 0, which is another way of saying, should we have a timer running, we say timeout start. To turn this relay off, all I'm going to do is just copy and paste this method, delete the counting increment, make sure we're digitally writing low instead of high, and then we'll stop the timer. Because the whole point of the timer is to keep track of when we don't receive an off signal. Oh, and of course I have to make sure I actually change the name from on to off. Now we have our method to set the timeout of our relay. So if we've received a timeout of 0, we'll want to get rid of our timer. So first we check to make sure our timer is not already null. So then we'll dispose of it and reset it to be null. Otherwise, we know we have a timeout that is greater than 0. So let's check if we already have a timer made. So if we do, that is, if timeout is not null, then we'll just say timeout change period to t. Otherwise, we'll create a new timer. And you can see that we used basically all the same arguments as before, except this time we have t instead of max timeout. Alright, now we're done with that file. We're ready to move on to our INO file. Alright, I have my INO file open. You can see that it just has a setup and a loop and a few comments. I'm going to delete most of these comments. We will need a setup function, but we will not need a loop function. So at the very top, probably as you would expect, I'm going to say include relay.h. I'm just going to add a constant here at the top, num relays. This obviously you could change if you were using a different number of relays. Unlike before, where I just had several different integers which were my relay pin numbers, I'm going to instead create an array of my relay ports. This way it'll be a little bit easier if I want to change my number of pins. But I'm still going to use the same pin numbers as before, so D0, D1, D2, and D3. I also want to keep track of how many pings we get over time. And when I say keep track of how many pings, what I'm going to add, in addition to everything that we talked about earlier in our relay class, I'm going to add a function which just is a ping to the electron. So the idea is the server can just basically ask the electron if it's alive and it will say yes. So I also want to keep track of how many times the server has asked me for a ping. I'm going to create a default timeout in case we don't get passed one by the server. And I'm going to set this to be the equivalent of 2 minutes. Remember, this is in milliseconds. I'll also create a current timeout variable, which right now will just be the default timeout, but that is what I'll change if I'm using something different. Then I'll also create an array of relays. So what are we doing in setup? We'll want to create each of our relays, so I'm going to create a for loop that iterates over my array of relays. So you can see that for every pin in my array, I'm calling the GPIO relay constructor. So using just I as the ID, and then the pin number as its pin number, obviously, and whatever my current timeout as the timeout of it. I'm also going to set up a few particle functions, just like before, except instead this time they're going to be request ping, relay on, relay off, get timeout, and set timeout. And we'll of course have to define all of those as well. I'm also going to register the total pings variable with the particle cloud just to make it easily accessible. Okay, that's it for our setup function. Now let's go ahead and define all of these functions. The request pings function is going to be pretty simple. As usual, this first line is going to look the same for all of our particle functions. They're going to say it returns an int, then whatever name we gave it, and then it's going to accept some string. First, I'll want to increment total pings, because that's the whole reason we have this total pings variable. I'm going to create some int, which I'll just call ID, and I'll convert my input to an int, and then just return that, return my ID. Next, we have our relay on function. So this is going to receive the relay number as an argument. So we'll just take our input and convert it to an int and have that be our relay number. Then we're going to make sure this is a valid relay number. So it has to be greater than or equal to 0 and less than our number of relays. So if all of that's true, we'll say relays relay num. So from the relays array, which is our array of relays, we'll access number of relay num and turn it on. And then we'll just return our relay num. Our off will look very similar. In fact, it's going to be the exact same thing, just with a different name, with the off function instead of the on function. Our get timeout function will look basically as you'd expect. We're going to just return an integer version of our current timeout. And then to set our timeout, We'll convert whatever value is passed to an integer. So if that value is bigger than 0, because remember, if we're past a timeout of 0, that basically means we don't have a timeout. We'll go through each of the relays and change their timeout. And then I'll change our current timeout to be whatever we were passed, and then just return back that value. And now our code is done. Our process for compiling and flashing our code is going to be pretty similar to before. I'm still going to say particle compile e, but I'm not going to specify which file I'm going to compile. Instead, particle just figures it out based on what project I'm in. You can see that it creates this binary file. Since my electron is in DFU mode, I can just say particle flash USB, and you can see that I've flashed what I've compiled. Side note, notice that I'm in the main project folder for my electron, so you want to be in that root directory as well. And then we can call our various functions in the same way we called our old control relay functions. So I can say particle call demo electron relay on 0. And my relay turned on. Similarly, I can turn it off. I can get my timeout, and I don't have to worry about what arguments I'm passing. And there you can see it passes back 120,000, which of course is 2 minutes in milliseconds. I can change this timeout, and I'm going to set it to 5,000, just to demonstrate. It's probably shorter than we would actually want. And then I say particle call demo electron get timeout. This time it returns 5,000. And I can say particle call demo electron relay on. Let's do 2 this time. And then after only a few seconds, it turns right back off because I changed my timeout. Lastly, I want to demonstrate all of the ping functionality. To view my particle variable, I'll say particle get demo electron total pings. You can see I have 0 pings. I can say particle call demo electron request ping, and then any number I want. I'm going to put 562. And it passes me back that same number. And when I call get total pings again, you can see I now have 1 ping. So there you go. We've made our code object oriented and added new functionality.